Hey guys, and welcome back to a new video. This is Mohsen, and today we are going to start building a powerful and fun application. This application will show us the best day to go for cycling among the 5 future days. The data are coming from the API, the OpenWeather Map API, and we are going to build an algorithm together to calculate the data and tell us which day is the best day to go to cycling. This video is the first part of the playlist, and in this video I'm going to show you the main structure of the project, the application itself, and we are going to check some of the files and the classes that we need them and the dependencies that we need for the application. And in the next videos we are going to implement the data about the retrofit setup, about the clean architecture and the MVVM design, and finally we are going to build the whole project. So be with me in this playlist by subscribing and giving me a thumbs up, and we are going to build this powerful application together. Let's get started. As I said, we are going to build an application that takes the weather data from the OpenWeather API, and based on some factors it will calculate the best day to go for bike riding among the future 5 days. The idea is like this. Let me open the application and show you. Here we have the temperature, wind, chance of rain, weather condition, and the humidity. And based on all of these factors, it will give us a score by percentage. And you can see here, it can be good, excellent, moderate, poor, and dangerous. And here is your location, and this is the today's date, the best date among the future days. And there is description for this day, and each day also has its own description, just like that. Moderate conditions, be prepared, or great condition for a ride. That's it. And each item also has its own description as well. We have the temperature here and a progress bar to show the percentage of the total and overall score, and we created this percentage by canvas. Okay, let me show you what do we have here. This is the main look of the application I showed you. It has these technologies: Kotlin, Jetpack, Compose, Retrofit, JSON for the serialization, and deserialization, Coin for the dependency injection, Coil to display images and icons, Google Play service location to check your location, and material tree to design the layout. We use OpenWeather Map API to catch the weather data, and we have the custom theme, and we have these screens in this application. We use the weather data layer. We have data models for the daily forecast, and we have the retrofit API interface and repository pattern. I use the MVVM pattern and clean architecture in this application. The dependency injection is Coin, and we use the view models and state management. And also for the location handling, we use I use the runtime permission and fetching users current location. The algorithm is calculated based on the factors I told you: the humidity, the wind, the chance of rain, and the temperature and the weather condition. And we have some recommendations for the users. And the UI components are card, list, progress indicators, icons, and images. And the layout is responsive. The icons are loaded by Coil, as I said, and I use the error handling to show the errors for the connection between the device to the API or something like that. And at the end, if there is error, the user can hit the try again button and again send a request to the API to receive the data. Let's go to the Android Studio and see what do we have there. As I said, I use the clean architecture. If you don't know what is clean architecture, I've built a video about it and I will put the link of this video in the description. You can watch it and come back here later. Okay, here you can see the data, domain, and presentation, which are the main packages of the clean architecture, and dependency injection has its own package. And in the domain for now, I have the model repository and the use case, but in the data, DI, and presentation, still I didn't put anything. We are going to build this application together, and step by step, I'm going to create the classes and files inside these packages and the sub packages as well. So let's start with the main activity. This is the raw main activity, nothing else, the hello world. So we don't need it for now. Let's check the dependencies. This is in the catalog. You can see these dependencies. As you can see, by the date of today, 26th of August 2025, that I'm recording this video, I have the most updated dependencies. I use retrofit, HTTP, JSON, coil, location, and etc. And here you can see them, the implementation of these dependencies. Let's go a bit to the right if you want to write it by hand. And in the build.gradle.kts modular app, you can see these lines: the view model, retrofit and HTTP and JSON, coil, location, and coin. And here you can see the compile SDK is 36. By today is the most updated, and I'm using the Kotlin Compose plugin because I'm using the Kotlin version 2.2.10. To use this, you need to use Compose plugin. And also I'm using the Java version 17, and that's it. Add them, sync your application, and you're ready to go. Okay, here in the model, we have two files. One of them is the weather models. Let's go to the Postman and see the full URL that we should have for the API call. This is the URL. You should go to the OpenWeather API and create your own API key to use it. Here we have the response after sending this data. You will receive this data. The coordinations, weather, base, main, visibility, wind, clouds, and that's it. Delay. So as you can see, the weather has ID. For today, for these coordinations, this ID is 800. What does that mean? Here in the documentation of the openweathermap.org website, here for the icon, you can see 01D. There's a table here that shows if you have this, the icon will be this. And for the night, will be this, and till the end of the table. And we have, if I don't make mistake, 8 groups for the weather condition. By 202, 232 is thunderstorm, 302, 321 drizzle, rain, snow, and the atmosphere problems, just like smoke, dust, fog, sand, ash, tornado, like this. And group 800 is the clear sky, and the group 80x is for the cloudy sky. We are going to use all of these numbers to check the weather condition and use it here and this one. Okay, so as you know, always I'm pressing Ctrl A and copying these items and creating the data classes, and that's it. Let's go to the Android Studio. So here we have the proper data classes based on the response that we are going to receive. The main class is the weather response. The entire response will sit inside it. It has the city, this data class, a list of weather item. Here is the weather item, and list of daily forecast. Here is the daily forecast data class. I'm going to scroll up slowly if you want to stop the video and write them by hand, but you can find the source code in my GitHub. I'm going to upload them today, and if you are watching the video right now that I'm publishing it, you can see the available codes, and later after we finish the whole playlist, you can see the entire codes. And also I'm going to put the list of the videos of this playlist in the first comment of each video, and you can check them. If at the time that you are watching the video the whole playlist is published, you can find the entire videos, and if not, you can find the videos that are already published in the channel. Okay, here you see the city has its own ID, the name, country, coordinations, latitude, longitude, date, the main weather type, the weather, and the wind, chance of rain, temperature, the ID of the weather, the speed of the wind, humidity, and that's it. All of the data that we need to calculate the percentage of this score. Okay, there is another file, and here we have created a data class for the bike riding score, which is the final score that we need. And enum class for these tags: excellent, good, moderate, poor, dangerous. You can see them here. And for the bike riding factors, these factors are creating this percentage as well. So the icon, the description, the weight of each of these items, and the score, and the name. What's the meaning of the weight? Later I'm going to explain it for you. For now, just accept it like this. Here in the repository, I have an interface. It has the suspend function, get weather forecast. The latitude and longitude are coming from the location service, will pass to this function, and based on this we are going to receive this result, and finally it will sit inside this data class. And the next thing is the use cases. If you watch the video about the use case, you know that the domain layer and the presentation layer are connected together by viewModel and UseCase. So viewModel and UseCase are connected together to pass data between these two layers. So here we have the get forecast use case. The use case will take the data from the repository and will pass it to the viewModel. It's not such a big deal. We have the suspend operator function invoke to run it by the suspension in the coroutine, and using invoke to make this class just like a function to be able to call it wherever we want inside the application. Again, we pass the latitude and longitude. The use case itself doesn't have any connection to the API, and the connection of the use case through this interface will be run. So again, we have this result, and it will sit inside this repository. In the weather response. So the full data will be passed to the viewModel later to be displayed to the user or to be used wherever we want it. Last but not least for today, we have this calculate bike riding score use case. We have operator function invoke again. We are going to pass the daily forecast to this, and it will give us the bike riding score, and that's it. So we have a value of the factors, which is a mutable list of bike riding factor. And each of these items that we have here, the humidity, weather, chance of rain, wind, and temperature, will give us a score, and we are going to add them one by one inside this factor, and based on that, the summation will be the percentage, the final score. Let's go all the way down and start from the end. Here we have a function to capitalize the strings. In some of the data that we are receiving, we have lowercase strings, and we need to capitalize them. So we are going to use this function to do that. Okay, we have 5 functions here to get the icon of the factor, like the humidity, the weather, the chance of rain, the wind, and the temperature. Okay, here we have 5 functions. I'm going to explain one of them for you. If, as you know, the percentage is the unit of the humidity in the weather. So if it's less than 30%, okay, this is the icon. If it's between the humidity, between the 60 to 40%, this is the icon, and etc. till the end. For the weather, the numbers that I showed you on the table in the documentation of the weather API, we are going to use them here. Between 200 to 232 is like this, and you can see the all number. Clear sky like this, the cloudy like this, and else this. Chance of rain less than 0.1 millimeter till this. And the wind, we are going to convert the meter per second to kilometer per hour. This is meter per second. Okay, actually this one, the wind speed comes from the API is meter per second. We are going to multiply it to the 3.6, and it will be kilometer per hour. And here we have the icon, and the temperature like this. We have 5 more functions for the descriptions. As you can see, each item here has its own description below it for the temperature, wind, and etc. The same as the icon, we are going to calculate and not calculate actually. We are going to submit one of these string values, one of these sentences based on the data that we are receiving here. Okay, and till the top for all of the 5 main factors that we have here. Okay, and also here we have another function. We are going to pass the score, the final score that we calculated to this, and based on the percentage of this score, it will give us one of these tags to display it here in the card. Okay, what else? Okay, now again we have 5 more functions to calculate the score of each factor individually. The humidity, the weather, the chance of rain, the wind, and the temperature. Each of them will be calculated, and it will give us a percentage by type of integer. So the temperature will pass to this function, and we are going to check. If it's less than -10, it's too cold, so it earns 0%. If it's like between -10 to 0, 20%. If it's between 0 to 10, 60%. Between 15 to 25 is the optimal range, so 100% of the temperature, and etc. For the wind, the same. For the chance of rain, the same. For the weather score, again the same. And for the humidity, again we have its own percentage. So till now we got 5 percentage, and now we are going to combine all of them to achieve this final percentage here, which is the final score. Here, the total score comes from the factors, sum of the factor score and the factor weight. Now we have here 5 values. Let me a bit make it smaller to see at least 2 of them in the screen. Okay, for example, the temp score and the wind score. It will sit inside this value. Okay, it comes from this function that like second ago here down below we were talking about them. The percentage were calculated and is passed back inside this integer. Okay, so we have now inside this temp score the percentage of the temperature. For example, for this one we got like 80%. For this one we got like 70%. For this one we got 50%. For this one we got like 60%, something like that. And now we need to sum all of them to achieve the percentage. But we cannot calculate the score like this, that we have 5 different numbers, 5 different percentage. We are going to sum all of them and divide them by 5. No, it's not like this, because the temperature or the chance of rain doesn't have the same weight, the same effect on the final score, just like the humidity have. So here for each of these factors we have this. We call this variable, and we add the bike riding factor into it. After calculating the temp score, for the temp we have the name of it. Where is it? It's here. The temperature, the temp score. The weight of it is hard code. we decide to give 20.25 of the weight. The final weight is 1. Let me somewhere here write it. So 0.25 plus 20 here, 0.20 plus for the chance of rain we have 20.25, and here 0.25 plus the weather has 20 and the humidity has 10. 0.20 and plus 0.10, so equals to 1. And I said that the final weight is 1. So the effect of each factor is like this. It's not the same for all of the factors. So the temp has 0.25, the wind has 0.20, chance of rain 0.25, weather 0.20, and humidity 0.10. Here we have the temperature, we have the temp score, we have the weight of it, we calculated the description. We didn't calculate it. We got the description and we've got the icon. Down below we have this function. You remember them? Okay. And finally, we are going to add all of them to this factor. The factor was a mutable list. So it has now 5 items. Each item has the data for the wind, chance of rain, temperature, and etc. And later we are going to use this list to see this data here. And last but not least, out of the factors, we are going to have the sum of all of the items of the factor, and the score of them and the weight of them will be multiplied together, and we are going to convert it to integer, and it will see to the total score, and it will return the score, recommendation, and the factors, and overall rating for our day, and which is here and here and here. You can see them. Okay, I hope it was not so hard for you. I tried to divide it in different pieces to make it clear. If you have any question about this part, write them down below in the description, or you can go to the website and fill the questionnaire form in the contact by scanning the QR code down below, and write your questions, and I'm going to answer them as soon as possible. Again, you can see all of the codes inside my GitHub. Thank you for your time. If you have any question, as I said, write them down below in the comment box. I will be so happy to read and answer them. Give me a thumbs up for this video, please. And if you haven't subscribed yet, please subscribe to the channel to be aware about the next videos. Till the next video, happy coding. See you.